All right, IM2 classes. Today we are solving nonlinear systems of equations. So we are actually going to be looking at um, systems with a quadratic and a linear equation. So where the solutions are. So similar to when we were solving quadratics by graphing them, the solution is going to be at an intersection. You're just solving and finding the zeros of a quadratic. The solution is where the graph crosses the x-axis. Here it's a system of equations. So the solution is going to be where the graphs intersect. So we have the we have linear lines and quadratics. If they never intersect, there's no solution. If they intersect at one point, there's one solution. And then if they intersect at 2 points, like we have here, that's two solutions. All right. So we're going to be graphing a quadratic, and we are going to be graphing a line and just looking for the intersection. Whenever we're solving by graphing, what we want to do is actually use a graphing utility. So graphing calculator or Desmos, that's going to be the easiest thing for us to do, the most accurate thing. If you have those available to you, that's what you want to use. Graphing these by hand is no, that's going to be harder. You should do it algebraically, and we're going to go over that after this. But if you're going to just solve them, plug in the equations in Desmos or a graphing calculator and just look for the intersection. So here in red, we have 2x squared plus 5x minus 1. That is the quadratic, that parabola here. Then we have in blue is y equals x minus 3. And they intersect here at the point -1, -4. Right? If you're doing it by hand, that's just going to be long and tedious. We don't want to do that. So let's do an equation here. So x squared plus 4x minus 4. So I'm going to switch over to Desmos. I'm going to switch my view here. Switch over to Desmos. I'm going to need to remember that. So new share, Desmos. Here we go. So here we have Desmos. I'm going to enter those equations we had. It was y equals x squared plus 4x minus 4. Get a nice parabola there. And then the linear was 2x minus y equals 2x minus 5. So you might need to scroll a little bit to find where they intersect. And so here it's the 0.17 if you want to like zoom in on that. The point -1, -7. That's it. So that has one solution. That's not going to intersect anywhere else. Yeah, so that's all you need to do. If it intersects in more than one spot, you'll want to do those. So let's the next one. Let's look at here. I know you can't see the equations. I'm just going to type them in, so I don't have to keep switching back and forth. The next one is going to be y equals -x minus plus 6, and then it's going to be y equals negative 2x squared minus x plus 3. So let's see, guys, zoom out fine, and they have no solution. So all you're doing is looking for an example where they intersect. That is it. Let's go back to our slides here. So, okay, so screen sharing stop. Let me try that again. There we go. All right, so we have negative x plus 6, or no, we already did that one. So here, what we're going to do is solve them algebraically. We're going to use substitution. You may remember using substitution in IM1. But what we are going to do is I'm going to take this part here, negative 2x plus 3, and I'm going to substitute in for y up there. So these are both equal to y. I know y is equal to -2x plus 3, so I'm just going to change that one. So I'm going to have -2x plus 3 is equal to x squared plus x minus 1. All right, and then I'm going to solve this. What we want to do here, because it's a quadratic, we want everything on one side of the equation. So I am going to add 2x to both sides. Make sure you add it to its like term. And then while I'm at it, save some time, I'm also going to subtract 3 from both sides. Subtract 3 from its like term over there as well. So -2x plus 2x cancels out. Plus 3 minus 3 cancels out. I just have 0 over here. And then x squared. X plus 2x is 3x. -1 minus 3 is -4. Now from here, we have options of what we can do to solve. What I'm going to do is factor. So you can try completing the square. Completing the square is probably not a great idea since this is an odd number, and then you'll have to deal with some messy fractions. You can also do quadratic formula, but this one will factor, so I'm going to factor. Using an x factor, on top is going to go -4, on bottom is 3. Factors in -4 that add to 3. That's going to be a +4. Okay, positive. Great. Isn't that fun when it does that to me? +4, -1. So +4 times -1 is -4. +4 plus -1 is +3. So I get 0 is equal to x plus 4. And then x minus 1. Don't need all this down here. We're not done yet, so we have the factored. And so remember from here, we want to do the zero product property. Since this product is equal to 0, I'm going to separate them out and set them both equal to 0. So x plus 4 is equal to 0, and x minus 1 is equal to 0. And then I'm going to solve them individually. So here, I subtract 4. Right? X is equal to -4. On this one, I'm going to add 1. So I get x is equal to +1. So if we were to graph it, we would see those two graphs intersect at 2 separate spots. Let's just do one more example. I'm going to do the same thing over here. I'm going to take this whole portion, and I'm going to look at that. Don't even have to erase it. I'm going to substitute that in for the y up there. So I get 5 minus 3x is equal to -3x squared plus 2x plus 1. So same thing, I need everything on the same side of the equation. It's going to be tempting to move this stuff over here, but since this is a -3x squared, factoring is a little bit easier if this is positive. So what I'm going to do is I'm going to move all this stuff over to the left side so the x squared term is positive. You can still factor if it's negative, but then it gets a little messier. It's just a little bit easier if it's all positive. So just move everything over. So subtract 1, make sure the things that have like terms, you're subtracting them from their like terms. All this stuff here cancels out. I'll have a +3x squared. I want this in the correct order. I want it in standard form, so I'm going to have the x term next. So -3x minus 2x is -5x. And then 5 minus 1 is a +4. That is equal to 0. Did I get that in there? Yeah. Great. So here, this looks like we can try to factor it. So 3 times 4 on top is going to be a +12, -5 on bottom. So factors of +12 that add to -5. I can't think of anything. Things that multiply 12 are 1 and 12, 2 and 6, 3 and 4. None of those are going to make a 5. I'm looking at them, seeing if I made a mistake somewhere because I was hoping this was going to factor. It doesn't look like it's going to factor. So since it doesn't factor, we have our other options. We can complete the square or quadratic formula. Complete the square is not a good option on this one. 2 reasons. One, it has a 3 in front of the x squared, that'll make it harder. And then the middle term is odd. And so we'll have to do some messy stuff with it. So let's go ahead and do quadratic formula. So A is 3, B is -5, C is 4. I am going to do the discriminant first. So the discriminant is B squared minus 4AC. So I'm going to replace the B minus 4 times A times C. So B squared is -5. A is 3, C is 4. So -5 squared is 25, minus 4 times 3 is 12, times 4 is 48. So 25 minus 48 is -23. Look at that. This has no real solutions. Good thing we just did the one where we know how to do with complex solutions. So I'm going to continue this with the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, from here, I just need to replace the b. I already did b squared minus 4ac, so I just need to replace that part. And then 2 times a. So b is -5. Square root b squared minus 4ac, the discriminant is -23. And then 2 times a, that's 3. So -5 is a +5, plus or minus square root of 23. That is not a perfect square. 23 is in fact a prime number. So that's not going to simplify, but since it's negative, we're going to pull an I out of there. It's going to be I times the square root of 23. All over 6. And for our complex solutions, we can just leave it like that. That actually does not simplify beyond that. You can split it up and write as two separate answers as 5 plus I root 23 over 6, or 5 and 5 minus I root 23 over 6, but this is just fine as there. That will do it for this lesson. I think that's going to be it for quadratics. We'll see you guys next time. Not exactly sure what we're doing next time, but we'll figure it out.